Hello everybody. We're going to continue with the continuous integration hands-on lesson here in this video. It will be very short, and everything we do here you can do directly from your web browser. You don't need to do any work in a terminal. And what we're going to do is add some continuous integration testing to the Hello Numerical World repository, which contains software you've already seen before. It contains, by and large, the same code you saw on Tuesday for the hand-coded heat equation lesson in the numerical track. So you can follow the links to the repository that were posted in the slides or posted elsewhere in the chat, or I'm just going to go to github.com, and then I'm going to search for Better Scientific Software site here. Better Scientific Software is actually an organization, which on GitHub, organizations and users are kind of the same thing. So if I go down to users there, I find the organization Better Scientific Software. And the repository I want to work with is this one, Hello Numerical World App Test 2020. Turns out there's a number of different repositories here, and I'm honestly not sure if they'll wind up being listed in the same order on your when you go here, but Hello Numerical World App Test 2020 is the one you should go to. So here we are in the repository, and you should see a lot of code here that looks basically the same that you've seen either in lessons earlier in the week or in lessons earlier in the day on the Better Scientific Software Tutorial Day. So what we want to do is add continuous integration testing to this repository. We can't do that working directly in the repository. The first thing we need to do is fork it. So come up here to this button in the upper right called Fork. And because I'm a member of many different organizations, when I go to fork, it asks me which organization I want to fork into, and I'm just going to fork it into my personal space. I don't want to fork it into any of these other spaces. So I select myself. This may take a minute. It's basically on GitHub servers making a complete copy of the repository over to my personal space. And now we're here in my personal space in that same repository. And you'll notice underneath it says forked from, and it tells you where it came from too. So what we want to do is we're going to add Travis continuous integration. Remember, that was one of the examples that I mentioned in the slides earlier today. So mainly because it's actually quite easy to use. So I'm going to say go add file, and I want to create a new file here. And we have to give it a very specific name, .travis.yaml. That is the requirement to use Travis CI's services. They require that the name of the file be .travis.yaml and it be in the root directory of the repository. If we were using some other service provider in the cloud, they would have a different file name, maybe at the root, but maybe in some other location within the repository. So the first thing that Travis CI requires is specify a little bit of metadata for the project. I believe this metadata is necessary so that it can launch an appropriate virtual machine to run the actual tests in. That's what's happening behind the scenes is the Travis continuous integration service provider will actually run a virtual machine in which all these tests are performed. And there's a little bit of metadata that's required in a travis.yaml file. To be honest, I don't actually know if it's even required, but I have not seen travis.yaml files that don't contain some of this. So we're specifying the language here as C++ and the compiler as the GNU compiler collection. So that's some metadata. Now we're at a point where we can write the logic that tells it what work to actually do to exercise a test. Now if you're, and we do that with the Travis keyword script. These keywords, by the way, are specified by the service provider, in this case Travis. They have documentation that tells users how a YAML file needs to be structured, and in particular what some of the keywords are and what their meaning is. If you were using a different service provider, it's going to be a different set of keywords and a different structure to the YAML file. So we get down here to the Travis keyword script. That's where we're telling Travis, here's the instructions to actually run a test. And if you had a really complicated project, you probably would put all of your logic to run a test perhaps in its own script, And all you would do here is, maybe the script is named runtest.sh, you would just run the commands that are in that script. In this project, and just to give you a little bit of idea, we'll descend into the code here real quickly. In this project, a lot of the logic to perform a test is actually embodied in two places. One, in this check.sh file. All this check.sh file does is look at the results produced by running the heat equation. Remember, it produces some text files with the two columns of data, ASCII data, one column representing the x values and the second column representing the temperatures. It's the one-dimensional heat equation. And all this check.sh does is look at those values and confirm that they compare to values in some predefined, some baseline result. So that's check.sh, that's already in this repo. And then in Makefile, if you look at Makefile, already defines a check target, make check. That's a very common GNU target. That target depends on heat, so it would actually build the heat application with that being dependent on that target. And then it also depends on this output from running the heat application. And the recipe for that is right here. So this is how it produces that output, is actually running the heat application here. Basically, it just it basically tells it to run the heat application for a long time until it's converged. So this logic in the Makefile, triggering that logic, is all we really need to do from the YAML file. And we do that very simply with just make check. So that is the extent of our travis.yaml script for this very, very simple project. In order for you to see what's happening, I'm going to commit it on a branch here. I don't really care much what the branch name is. And by committing it on a branch, I'm proposing the new file to myself. This is a repository that I own, but I'm doing this to exercise some features that you need to see. It may be, I'll say this before we actually hit the create pull request button. If you're new to GitHub, you've never used it before, or you've never used it, had your account connected with Travis CI, my account is, any repository I have in which I trigger Travis CI uses my account resources to actually do that. It's conceivable you're relatively new to GitHub and don't have that set up, and so what you're about to see, you in all likelihood would not see. But I'll show a different way to demonstrate it in those cases. So here I'm doing a pull request into my own repository from a branch, and I'll just briefly show you what happens. What you will see happening here is it actually will trigger you see two Travis CI jobs here, one for the branch and one for the pull request. And notice the branch is in progress here. This should only take about 15 or 20 seconds to run. So the branch ran successfully, took 18 seconds, and said it passed. And now it's off to, it's only queued. It actually hasn't started running the pull request CI. Okay, now it's actually running the pull request CI. So what's happening in both these, launch a virtual machine, run everything. Launch a virtual machine, run everything I told you to do there. And so we'll wait for that one to finish. And then I'll describe what these two different Travis CI jobs were. Okay, both of those passed. Great news. I'm going to do show all checks real quick. So what were these two Travis CI jobs? One is for all the code on my branch. So it's basically exercising everything on my branch here. The other one, the pull request one, is for what would happen if I merged all of the code on my branch into main. It's telling me if you merge that pull request, this is the behavior you're going to see. So very often you might get passed in your branch, but not in the not in the actual pull request. But it turns out it passed both ways, and obviously that's because I haven't actually made any fundamental changes to any code here. I'm just changing the repository itself to exercise the CI. So we can also go down into, say, the branch here, either one of these, and look at the details. And let's look at the build log. This will take us now out of GitHub and over to Travis. And again, just to remind people, if you're new to GitHub and haven't connected your personal account with Travis CI, the steps you're seeing me take, you can't take yet, but I'll show you a different avenue to get there. So here we are in Travis, and we can see what was actually done. It launched a virtual machine. Up here, you can drill down to that information if you want. And then it basically cloned our repository, set some things, and then it got down here to the actual script. Remember I said all we needed to do to run a test is make check. That's this line right here that came out of the travis.yaml file, and that triggered all this activity. It built the heat application. It then ran the heat application according to certain specifications, producing an output. It then compared that output to a baseline result, and it says the make check exited with 0. So that means that the continuous integration passed. Okay, once all that's done, you see all the green lights here, we can actually merge the pull request. And I'll go ahead and do that. And I'll demonstrate a couple of other steps really quickly here, just for you to see. So now that's merged this travis.yaml file into main. We should see it's here on main. Now I want to do some additional things. I actually want it to do a coverage test. So how do I do that? I need to modify the the compiler flags to basically measure coverage. I want to know how much of the code base is actually covered by this test, and the way I can do this is cxx flags equals minus coverage, and then ld flags equals same thing, minus coverage, but I also have to tell it to add the math library as well in case it's not already there. And because I have a space between these two options to ld flags, I need to enclose that all in double quotes. And then I say make check. So now that's going to produce, when the tests run, that's going to produce some gcov files. And then I'm going to ship those gcov files over to yet another service provider. So this is another tag that Travis CI defines, the after success tag. And I'm going to do this, bash, sorry, basically what this is doing is launching a bash script on this virtual machine, and the bash script that it's actually launching, it's downloading from CodeCov and executing that. So it's using curl to download and execute that. The effect of that will be to upload all the gcov files to codecov.io and have codecov.io analyze it. And again, the reason this works for me is because I've already connected my personal account here with codecov.io. So I'll do, I'm going to do this on a branch again. I'll propose changes. Again, proposing the changes to myself for this test. Create the pull request. It'll go through the same sequence of operations now. Let's just confirm that one of these builds, I think the branch will go first before the pull request does. Right now it's showing their status as being queued, so they're getting ready to be run. Okay, so the branch is now running. And we'll just let that finish. That should take, again, maybe 18 to 20 seconds. And again, it's launching a virtual machine, doing according to the specifications of the travis.yaml file, and then running a make check of the code base. Okay, again, that ran successfully. So everything ran successfully there. Good deal. So we'll merge the pull request to main. Now, there's one additional step here, and that is to use, I'll go back to code, look at the travis.yaml file one more time, and that is change this check target to a check underscore all. I'll let you do this on your own, and then observe how the coverage changes from check versus check all in this case. And you should observe a difference in the total coverage from testing. Okay, so I'm going to cancel this. Now, I'd said that all works if in the past you've already connected your personal account up with GitHub and, I'm sorry, with Travis and with CodeCov. If you haven't done that, you can still exercise all the same things you saw me do here, but the way to do it is submit a pull request to the upstream rather than to yourself, to the upstream. So I'll demonstrate that next. What we've demonstrated already is how to exercise Travis CI from pull requests within your own personal space if you've already had the experience of getting your personal account connected up with Travis CI and CodeCup. If you haven't done that, that's fine. There's another way to actually demonstrate that, and that is by submitting a pull request to the upstream instead. So here we are in our same travis.yaml file on our fork, but instead of committing to a branch, I'm just going to commit it directly to main on our fork, and then I'm going to submit a pull request to the upstream. So that's going to be the difference, and the effect of that is when we submit it to the upstream, that will trigger all the CI in the upstream repo rather than in our fork of it, and you can still have some of the same experience. So we commit this file directly on main. Okay, so that's been added to our main. Again, that's in our fork. Now we're going to go to the upstream here, and now we're in Better Scientific Software, Hello Numerical World, and we're going to create a pull request. So here we are, new pull request. By default, the way that pull requests work on GitHub's interface is to merge within branches within the same repository. However, there's an option here. If you need, you can also compare across forks, and that's what we need to do because we need to merge work that we did on our fork into the upstream here. So when we click that, it presents us with a default thing, which both of these are still out of Better Scientific Software organization, and we have to go to this pull down here on the right and select our fork of that repo. So for me, that's Mark C. Miller 86 and then the repo name. And now notice here's the changes that we made to this travis.yaml file. All you need to do at this point is do a create pull request, and you should see some of the same steps you already saw when I was demonstrating it against my own in my own personal space. The reason I actually don't want to press this button right now is it will pollute the upstream repo with pull requests before we've had a chance to use it in our training session, and I just want to avoid that. So I won't actually hit this button, but if you do, you should see a lot of the same behavior with it triggering Travis CI in a couple of different places. I'm trying to think now because it's on main. You probably won't see a branch CI. You'll only see the pull request CI that gets exercised, but you should see everything else. And then go in after you've made that pull request. You can go in and make adjustments to it by adding adding the additional line for CodeCup that you saw earlier, and then changing make check to make check all with coverage. So sorry I can't demonstrate more of this, but I just feel like I don't want to press this button until you all have had a chance to play with the repo during the training tomorrow. Okay.